All right, Geometry 2. We are working in 4.03 coordinate applications and we're looking at splitting the distance. So finding the point that is some ratio between two other points. And we're going to start with a situation where we have our first point is going to be right here at 0, 0. And our second point is going to be at 6, 6. And what we want to do is 2/3 of the way from 0, 0 to 6, 6. So 2/3, oops, sorry, uh, 2/3 of the way from 0, 0 to 6, 6. And so what we really are going to do here is, so we're actually looking along this line right here. That's what we're interested in. But what is going to be helpful for us is to think about this right triangle here, like this. And so we're going to look at 2/3 of the way from 0, 0 to here, and 2/3 of the way from here to there. And so that will give us this will tell us the x value of 2/3 of the way along there. And this will tell us the y value of 2/3 of the way from there to there. So that is the process that we're going to be going through. So what I need to find the distance, this distance right here. And that distance is 6. So we can call that delta x. And this one, the delta y, this distance is also 6. And so what we're doing is 2/3 of 6, and then we're going to add that to 0 here. So we're saying 2/3 times delta x. So that's going to equal 2/3 times 6, which is 6 over 1, which is 12 over 3, because remember we multiply across the numerators to get 12, multiply across the denominators to get 3, and that equals 4. So that tells us that, and I'm going to highlight that in purple. So 2/3 of the way from here to there is 4 units, 4 units from here. So 1, 2, 3, 4 right there. So we're going to put a purple point at 4 right there. And then on the next one, we're going to be talking about 2/3 of the distance from here to there. And in this situation, it's going to turn out to be exactly the same. So we have 2/3 times, and in this case, delta y, which is 2/3 times 6, or 6 over 1, and that's 12 over 3, which equals, and in this case, it's 4 again. And I'm going to do that one in green. And so we add 4 from here. So 1, 2, 3, 4 is going to be right there. So I'm going to add a green dot here. And now if I match these up, there's my point right there. So the point that is 2/3 of the way from 0 to 6, 6 is the point for, excuse me, that should be purple because the purple one was our x value. 4, and then the green one was our y value, 4. And so that is the answer here in this situation, 4, 4. Now, it gets a little bit more complicated when we don't have one of our points or our starting point as 0, 0. So let's look at a situation like that, because it's always nice to see the more complicated ones as well. So our first point is going to be the point, and I'm going to be using the example 2 that's on slide 2 of this section. So so we're finding point C, find C that is located 1/4 from A to B. So 1/4 from point A to point B, and A is going to be our point 2, 4, right there. And B is going to be our point 4, -2, right there. So I'm going to say A, and B is 4, -2. All right. So in this situation, we're looking for ultimately this point, or that along that line, 1/4 of the way between A and B. So it's going to be about right there, somewhere like that. I don't know exactly, but somewhere like that. So what we need to do then is we need to remember that we're looking at this triangle where delta y is equal to, well, we're going down since we're going this direction, so it's going to be a negative. -1, 2, 3, 4, 5, 6. -6. And our delta x is going to be this direction to the right, so that's length 2. So what we have here is our 1/4 is going to be what we're multiplying -6 by, and also what we're going to multiply 2 by. So we have 1/4 times our delta x is 2, and that's going to be 2/4, which is 1/2. Now we take that 1/2 and we add it to the x value where we're starting from. So I'm going to take the green and add it to that. So we're adding that 1/2 to 2. Because we are moving to the right, that's why we're adding. And that's going to be, is going to be 2.5 or 2.5. You can think of it either way. That's just fine. So the x value of our point C is going to have the value 2.5. And I'm going to make that red. That's our x value. And next, we take that 1/4 and we multiply it by, this time by -6, because we're going down 6. That's our delta y. And that's going to equal -6/4, which is -1 and 1/2. Because 6 goes into 4, or 4 goes into 6 one time with 2 left over. 2 out of 4 is a half. So it's -1/2. And I'm actually going to copy all this and take it over to the next page so that I have a little bit more room to work with. And bear with me. Any questions so far about what I've done? Okay, great, great. So we take the y value here, which I'm going to make pink. And so that's going to be where we start from. So we start from 4, and then we subtract, because it's we did the -6 times, or divided by 4. We are going to subtract from that, so that 4 is right there, and we subtract 1.5, and that's going to give us 2.5. And that will be the, turns out they're the same value, which is kind of annoying because it's maybe not as obvious exactly what's going on, but I think we can deal with it. So that's the y value of our point. So our point has an x value of 2.5 and a y value of 2.5. So 1, 2.5, 1, 2.5. And if it is not on my line there, then there is something wrong. So in this case, it is on my line, and that's good. Otherwise, something weird would be going on. So basically, the idea is you use a slope triangle, and you either add or subtract from your starting point. Now, in this case, A was our starting point, so we were going this way. If we were going this way, then instead of having 2 and 4 here and here, it would have been 4 and -2, because you could, in theory, go that way. It doesn't make any difference. All right? Any questions? Oh, so this is just an XY coordinate value. So from here, we go 2.5 to the right, 1, 2.5, and 2.5 up, 1, 2.5. Yep, it's just, so when we get to these points, this is our X value, this is our Y value of the coordinate point. Thank you. Anything else? Okay, all right, great. Thank you so much. I hope this was helpful.